review runs. I want to start checking the work that has been done for the machine week. So I'm going to start sharing the screen. Yeah, good. So here is the work that has been done. We have already the page, and which is good. I'm really happy that you started to put all the documentation together. Thomas, can you introduce me the work that has been done and do a little review of how you structure the work?
Sure. Okay, so the first thing we tried to do last week was to obviously to come up with an ID for the machine. So we did a little vote. Let's say that everyone thought of a different ID, and we put them together on Friday and try to decide which was the best one. So everyone did a little sketch of his own ID, and then we exchanged them and talked about them to decide what was the best one. So on the page I presented the different sketches that everyone proposed.
Where are those? Those are the sketches?
Yeah, so those three ones are Guillaume's ID. It was a machine that makes music. It works like a barrel organ, a street organ. So you turn the barrel, and it's a perforated sheet of paper, and so it makes music. It was supposed to be electronic, of course. Then my idea was to make a drawing machine. You can see the sketches here. I did two different sketches, two versions. And then Ludovic and Roman had the same idea of making a machine that makes cocktails, which was the best idea of the group. So this is the one we chose.
Perfect.
And so, yeah.
Go on. Sorry.
After this, we decided to choose this idea. We had to modify the sketches and to think of how it would actually work mechanically and so on, structurally. So we had to make another few drawings to find the perfect, the right structure for the machine. So that's the drawings I show after on the page.
This one.
This one is Frederick's drawing. It's not the final one, because on this one there's only one glass, and we wanted to have a row of glasses to be able to fill several glasses at a time. So it's a bit. You can go down again.
But okay. Your weekly gift.
Yeah, exactly.
I cannot miss it. That's good. Okay, then how you decided together to structure the work? Apart from before starting to go into the details, is there any?
We tried to determine which was the best task to attribute to everyone, taking into consideration the skills of each student and also his availabilities. And so it was not completely fixed at the time, but we thought it was better to attribute, for example, the fluid mechanics, so everything which is related to the distribution of the liquids to Frederick, because he has some experience with it. Guillaume was going to do the prototyping and also work on the 3D design of the and 3D fabrication of one of the parts, and maybe also programmation. Ludovic worked on the 3D model of the machine along with me. Roman will work on programmation and electronics and the code. And I would work on the documentation, the 3D modeling, and Vincent on documentation and prototyping. So that's how we decided to attribute every task to everyone.
Okay, nice. Can we organize it as well? Someone has the micro on. Do you have the earphones, right? I can hear my voice.
I do have earphones, yes, but maybe it's...
Okay, in any case, I would like to subdivide the task and organize the task by hardware and software. Okay, and as well, it's good so we can organize them by even main topics. This is something I would like to clarify as well. What I don't like about this organization of the work is that there is no index. Okay, so it makes it a little bit confusing to understand the structure of the page itself. As well, I would like to we'll do other comments, but in general terms, I think this idea of putting the proposal at the beginning, the different machine proposal, is absolutely great, very, very beautiful, and it's perfect as well that you talk about the task. This should be another session. Okay, so we should have, we should simplify a little bit, structure the presentation that you're doing, and let's go on from here on. Go on and explain me the rest. If this is not your part, even the others, or Romain or Guillen can talk and keep explaining. You don't have to explain everything.
Okay, so we spent quite some time trying to decide which would be the best way to build the machine, structurally speaking. So how could we put the bottles in what direction? How could we decide which axis would do what, and so on, and how to distribute the liquid. So would we use like servo motors? Would we use steppers attached to another type of element? And so for the bottles, we decided that it would be best to put them not completely with the head down, but like 45 degrees, to put a little less weight on the structure and to make it easier to work. This way we wouldn't need to use pumps as well, so it's maybe it's easier. This is a proposal of the structure that I draw when we discussed about it with Roman and Ludovic this weekend. And so after that, we thought the best way was to try to begin designing, because the structure would more or less come itself. So of course the essential part was to measure correctly the parts that we already had, being the shafts, the motor, and the screw of the motor. All of those are essential for the structure, so we measured it quite precisely with Roman and Ludovic, and also we had the Rhino file from MCM. So with this we could start the 3D design. The only thing which was different is that the shafts in the model are 50 centimeters, I think, and the one we had were 60, so we couldn't really use which was already designed in the Rhino file. So we decided to redo everything. It would be easier for us. So this is the first part when I began to. This was my task, the 3D design. So with
where
is the small part?
Which
just above.
About. Where is it?
Which
Sorry?
Chirac is well with me. Is here with me. We didn't understood which part are you talking about.
Which you redo.
The one that
The boxing system, which includes the shaft and the motor. The file that you send us on Slack, you know, the Rhino file. There's a plan for all the boxing system for the machine, for the axis.
Yeah, the official one.
Yeah, this part we didn't use it. We redid all the structure because there were differences in the length of the shafts of the rails, and also we were planning on using another type of material, not the same thickness.
Okay.
Unfortunately, I couldn't make the Grasshopper file work on my computer, so it was easier to redo it again from the start.
So you draw everything again on Rhino?
Yeah, except for the motor and the shafts.
What was the problem with Grasshopper?
The file couldn't work on my computer.
Are you trying to open it with the Mac version or the Windows?
Yeah, no, it's a Mac version.
No. Okay.
I don't have a PC at home, so.
Okay. I think that's the reason why, in any case.
Yeah.
Okay, then let's go on. Ciao, Romain.
So yeah, so beginning from the boxing system of the rails and motor, I basically managed to determine which would be the best structure for the whole machine. And I got a lot of help from Ludovic and Roman at this point because I was not sure of some of the choices I made. So yeah, this is the process that I used. An important part was also, for example, to design the bottles. It was just a way for me to visualize easily how they would fit in the structure. So I took a basic liquor bottle, I measured it, and I reproduced it on Rhino. I did the same for the glasses as well. Roman bought some glasses at IKEA this weekend, and so he measured them and he gave me the measures. So it allowed me to reproduce them as well. And so with all those informations, I worked on I did the little step-by-step work, and I finally came up with this structure for the machine.
Yeah, the structure looks amazing. It's very, very beautiful. I really like it. Okay, but what about the liquid?
The liquid, we were not sure, but we talked about two options.
About the liquid distribution, may I?
Yeah, sure.
Like, we have discussed a lot about how to distribute the liquid. The end part is the easy part. Like, we do kind of extruders to distribute the liquid, but the problem was to have quantity issues that would work. So we thought about two systems. First one was a pump, which was maybe the easy one, but not easy because the pump we have are quite strong for our purpose of a glass. And so we decided, the next image you see, part, to make kind of a tap that would be connected to the bottle. So I first draw this part of a screw with a hole. When you turn it 90 degrees, it stops the liquid. And when you turn it 90 degrees, it puts a hole in the row, so it distributes liquids. I just wanted to test the screw first, and then I drew another part you might be able to see on my site, on my personal project site, and I didn't give to Thomas yet, which is one with a servo motor support integrated to the screw. So you can put the servo motor directly on the screw and do the 90-degree movement. And we thought that with a little bit of Teflon, we could open and close the tab.
About rotating. Can we have a little video about it? Would be nice if we can show this logic through a video as well.
If you check on my side,
We'll put an animation.
there's no animation.
Okay.
There's a closed and open version. I took 2 photographs.
Wait, let me
45.
go there.
On my messy website.
Where is it? Machine building, huh? Okay.
This is the part with the servo. You can see on the first Rhino part. And then, if you look there, it go down. There, it's closed, and there, it's open. If you turn the screw 90 degree.
Ah, okay, okay. Closed and open.
Right.
Okay. I guess this part should be also partially documented there in the machine assignment. It's nice. It's also very good like this.
I couldn't the file early enough to Thomas.
Okay, so let's add it because it's an important part. Is one of the control of the liquid. Did you test it also with the liquid?
No, not yet.
Did you have the?
Not yet, because the latest part, if you go all up, which is not printed yet on the page, which we didn't print, we see you and not your screen.
Which part?
We see you, but not your screen.
Yes, I know. One second. Which part is not ready yet?
It is printed, but we didn't test it. It's the first Rhino file you see on top of page.
On the top of the page, yes. Which
you've got a small screw, and you can add a servo motor inside the file, inside the structure, so it is stuck, and you can control it directly with the servo motor doing the 90-degree part. But first, I wanted to test the screw and the whole design.
It looks interesting.
But
Go, Shira.
sorry, I just want to know, like, why it is not complete? Like, is there any complications or any issues, or just because of the time?
Right, I was out this weekend. I designed it. It was long, and it happens that intern at Roma did break all the printers we have. So I did print it at our partner's office, which is 500 meters from MoMA, but I couldn't test the part yesterday night.
No, that's okay. That's okay. No, I was just like wondering if there is a complexity of like doing.
An intern broke the machine. He was supposed to repair it, and he didn't. He's not an intern anymore.
Great, perfect, Guillaume. Very nice. I just would like to then keep adding this information on the machine week. Thomas, it's clear regarding the documentation. Again, what I told you, I really want this information to be structured in an understandable way. I think it's a great documentation. I just matter now of making it clear with the proper index at the beginning. Also, I will again for this page. The rules are the same for all the other all the other assignments. So every link or every reference should be posted at the beginning with a proper ID card, like Roman is doing every week on his page, and you are doing as well, I guess, if I'm not wrong. Okay, so let's add this extra step. The rest, I really appreciate the effort. It was a very good understanding. One last, just want to show you the. I want Okay. I would like, you see, I mean, I would like to have a clear overall review of the topic and an index at the beginning, and then we go into details for the machine. Okay. Apart from this, what is the next problem in terms of mechanical design that we have to face in order to achieve the final result?
I think that the first thing is we have to, because we didn't have time to actually assemble the machine. I mean, we did a first version in cardboard, but it was not really stable, and some parts were missing. So I did some modifications yesterday, and I cut a whole new kit in plywood this time. But I didn't have time to assemble it yet. But I think it will be pretty stable this time. And so we have to assemble it, to test it with the shaft and with the motor, and to see if everything is okay.
Okay, the fabrication part, I see that the prototyping part is another section of your work. Let's clarify the material that you used and even the different iteration that you did in order to have the final result. Because this one that I see at the beginning is in paper, right? It's in cardboard. And now you want to do one in wood, right?
Yes, exactly.
Did I understand? Perfect. Let's put it there. This is. I want to see. Imagine. I want to see this drawing, the one that you put here. Okay, and I would like to understand what is built in 3D print. What is the result of a 3D scanning? All the material that you are using in order to achieve the final result. I want to create a proper documentation. I'm not going to be a bit annoying with it, but it needs to be clear how to go through all of it. Also, for the glass material that you want to use, I mean, it's not a bad idea to even implement 3D scanning. To have some shapes or something a little bit more complicated that you can reach in terms of forms with the scan. Then there are missing. So the connection between
electronics, no?
the electronics is the step down this week, but in terms of mechanical part, yeah, I don't see any cable connection between bottles and the tube.
We know how, like basic plastic. And then
no, Guillermo, I cannot hear you, so it's difficult to understand what you say.
Okay, is it better now?
Yes.
Okay.
What you say?
So we've got some plastic tube to go from the bottle to the extruder. If you go up, we did buy some bottle tap, the yellow thing you can see.
Where is it?
Down. Just after the 3D printing, this.
Okay.
So there is one image.
So I did adapt the tab design to the tube we have and to this out of bottle. Next mechanical step, I guess, is both to move the carrier with the extruders that you see drawn just after, and to check the opening and closing of the bottles with the tap and the servo motors, just to check if we hold the quantity of liquid.
Sorry guys, but this machine making machine week is like one of the complex project of all the projects you do now, and there are a lot of different stages. So I think the best way to present is to have like video. So easily anyone can perceive easily, like to understand the whole process. Because like this documentation good, and then at the end you put a video of the actual product, like whatever it is, even if it is in cardboard, you just show around so that anyone can understand easily.
No, but I mean also I still have a little problem of understanding the final part.
I mean, it's not ready.
No, exactly. I miss still the idea and the topic we discussed, how we're gonna mix the liquid inside the glass when it's there. I don't see any rotation material. I don't understand how at the end you decided to do it. You know what I mean? Because there were a discussion with Frederic on rotating.
We decided that the first step would be to only distribute liquid, and if we can make one more iteration to shake liquid together to make cocktails. But for the moment, it's only distributing shots.
No, sorry, it's difficult to understand.
It's just distributing the liquid, and it's not mixing the liquid inside the glass. I understood.
What do you mean distributing?
Basically, just the extruder, let's say, will leave liquids. Will drop the liquid in the glass, and then you will have one liquid, then another, and another.
But the glass is not moving.
The glass is not moving. You have the.
You have to take the glass and put next to the.
No. This is moving. This is the extruder that is moving, and it's it's dropping the liquid inside the glass. Okay. The fact is that there is no mixer. I understood. Thomas, can you say some word about it? I have a little bit of problem with this final part.
Yeah, this part is actually the part where the hoses connected to the bottles will pass. So it acts as an extruder. So there's 4 of them because there's 4 bottles, and so one by one it will pass over one glass and distribute the correct amount of liquid. So if, for example, we want to do let's say a mix of 4 different liquids, because it's the recipe. There is a little amount of the first hose and a little amount of the second one, and etc. So yeah, and so there's a noise.
It's not me. I mean, we are not. The noise. Okay. Then.
So yeah, at the bottom of this part, there will be some I don't know how to call it. I think it's spout in English. It's a thing that you put at the end of a bottle. So we will put 4 of them to distribute the liquid. It will be connected to the end of the hoses, and the beginning of the hoses will be connected to each bottle through the tap system that Guillaume began to design.
Okay.
So yeah, we will electronically command the opening and closing of each tap connected to each bottle.
May I say something, guys? Saverio?
Yeah.
So for me it's okay what you did, but the problem I think is that you are going to pour the liquid through gravity. So you are just relying on the fact that the bottle is on top, and then you open the screw and the liquid goes down. And first of all, I'm not sure this screw would be watertight, so I think that as soon as you connect, all the liquid would go through, and also it's very difficult to select the right amount with the screw going out and closing and opening. And I think the best way to do it, and actually I think is the way that most of this kind of stuff are done, is to have a bottle just put on the table with the opening up, and then there is a little tube, and then there is a little pump that takes the tube, the liquid you want, and goes through the.
Yes. So, may I reply? In fact, just on the page when we are looking now, just a little bit topper, we explained this. Yes, we saw. Stop. Just going down a little bit, just a little bit here. There is explained here. In fact, yes, we saw all this solution, and we think it about the pump that names peristaltic pump.
Yes.
That means it doesn't touch the pump itself. It doesn't touch liquid. It passes always in the tube, and we have the rotation mechanism that push that compress each pipe just to push. That's it exactly. Just to push the liquid. The problem is to operate this. We need 4 motors. We just don't have it. And to buy them, it costs €18 per motor, so it's about €80. And we're just not ready to collect from each of us €80 to buy 4 motors.
Yeah, but I mean, why do we need the NEMA 17 stepper? You can use any stepper
we don't have any. But in fact, yes, you're right. And I think what we discussed between us, we told that we will start. In fact, the first version, the version number 1, that will try to use liquid using the gravity, and we will just count the time required to open. So we will make a kind of tuning of the machine, and we will make a table of results. So we will know the time required to fill up the shot. As it serves the shots for the moment, so the liquid nearly same consistency, except probably for the T-punch, but this will be another discussion. And the next version, as we say, okay, we have just only one axe, the X-axe. Probably the next version maybe will be realized with the X-axe and the Y-axe that will move the glasses to have few rows of glasses to serve at the same time. And we probably will switch to this kind of system of the pumping. And anyway, we need to test. We need to test it to understand that there is a mistake, and we absolutely need to use a system of the pumps that push the liquid. But yes, you are right, and we saw this, and we understand the problem. And we want to test. We want to. But no, you are reason to make this accent on this. But we understand the risks, and we want to try. And I think we will see. If it doesn't work, we have a solution. So we just pay €80. We just redo a little bit code of the moving, and instead of turn, we send the PWM just to move our steppings for the defined distance. And what is good with this solution that you talked about is that we know exactly the amount of liquid that will be served, just because between each pass of the pump we have the same distance between 2 compression, so it's deliver exactly the same amount of any kind of liquid, if it's different density or different types. We always have the similar size of the liquid.
And just to answer to your first comment, Saverio, for the water tightening of the system that Guillaume is actually is currently working on, we wanted to use some kind of tape which is used in plumbing normally, so it will act as a water tactizer, something to make it hermetic.
Okay.
Guys, about the bottle position, just one comment. Like using a gravity is a really good idea to make it more simple, the whole mechanism. But I would say, like, instead of servo, maybe you can also look into solenoid valves. You know, because the solenoid valves are very powerful and very quick, so you can really control, because servo takes time, you know, in order to rotate and all these things. So like rotation will take time, so that meanwhile you need to understand, like calculate the time when to start the servo motor to stop the liquid to get the right amount of liquid in the glass. So you can also look into this solenoid pump, which, like, normally, you know, those fountains, programmed fountains, they use these pumps, so that you can like in fraction of seconds you can close and open, and which controls the liquid very well.
we can.
What made us not choosing this system is that you need a lot of strength to press on it, and we were not sure to have enough power pushing on those tabs.
Really power to make work solenoid pump.
In fact, the solenoid pump, yes. In fact, now, Guillaume, you're talking about, we checked when we see the video right now on the screen, and we saw this bottles turn it over and the pumps press it physically. So we had one of the idea that was passed and we studied is to have a Z-ax that bring the glass upper and push this system that you usually see in the bar. But what Guillaume said is that such kind of system is really hard to press. So probably the stability of the machine and so on, it will be in game in this time. And about the valves, we also check it, but same problem. We don't have any in stock, so we need to buy them, and the price of them as well, 20 and plus euros. And the problem of the valves, we didn't find any that doesn't have contacts with the liquid or that are recommended for the food usage. So yes, we saw a lot of valves for the aquarium and so on, but there is no there is no marks that yes, you can use it for the food. And there is a direct contact with the liquid instead in comparison with the system that talked Saverio with the peristaltic pumps. There is no contact with liquid and the mechanism.
Okay, Roman, look, guys. It's okay. I see that you did a little bit of research, and I will wait for the prototype to have a final say on it. In any case, great. You organize absolutely in a good way. As usual, I'm very happy on how you did it. The drawings of this guy are amazing. So Ludovic, great drawings. You are the official sketch guy of the team, for sure. Beautiful drawing. And talking about drawings, this is how I want to see this machine. I want to have technical drawings exploded this way. So, and explain every part, like here, on how it's built. Okay, so put information in it, explain the material, do section drawings. I mean, it has to be a technical representation as well. Yeah. So try to use those things also a little bit as a reference. And now I want to move to the other. I put the link in our chat. Moving to Corsica and then Digiscope, I want to have an update, or also good to have a quick comment on the work that the students in Paris did. So,
just before, sorry, I will a little interrupt you. Just to say that this week Thomas works like enormous. He did the most of job, the practical around this project. Just to remark it, because he did a lot of remark about everyone except himself.
No, Thomas did absolutely a great job, and I know that I really appreciate it. So congratulations. I mean, really happy with what you did, guys. So Lorenzo, comments on what we did, and also an update on your situation there.
So basically, we're just today. I'm alone. I'm sorry, guys. So my students are still work in progress. Where we have the structure, and I can show you one picture here in Jan's page, but they're still like we're a little bit ahead. We already built the structure, and oh sorry, I just send you the link in the wrong page. There is a small a picture in Jan's page,
Lorenzo,
show you
can you share
the
your
triangular
screen?
structure is under
Lorenzo,
machine design. Yes, you hear me?
can you share directly your screen? And you can do it in Google.
Yes. So let me just close. I mean, let me show you guys the real structure. I'll be right back. So guys, sorry. So basically, what I did, this is the structure with the triangular shapes. So the student they're just working on the structure. They built the cabinet, and now they are working on all the documentation and trying to write down everything they did. So at the moment, we have some sketches upload in the Lucia Simeoni website, but I mean, it's they're still working. Besides that, we have one student free job who is working on already on the programming area. He's trying to setting down all the motors. Yes, and the step motor. Did it work? Yeah. Awesome. So yeah, we have only a lack on the documentation, but besides that, the machine is going fine.
Lorenzo, sorry, I was with the mic off. No, I was saying this is the structure the students were discussing last time, and they started to. Well, as soon as there is some documentation on, probably will be easier to discuss. Also, one technical comment between us, as instructors. I connected the page, our machine week, to the lab main page. And I guess you're gonna do the same for yours, no? So
yeah, right.
Okay.
Yeah, basically they just work harder to create the structure and trying to figure out the boards. Yeah, the idea is like to work this week on the documentation and make it better.
Okay. Here as well. It's complicated now.
D'accord. Ok. Ok. Bon, il n'y a pas de souci, de toute façon, je voterai plus tard. Merci.
Ciao, Mattia.
Ciao. Ai, perdon.
Good. Comments, Lorenzo? Sorry, but just a comment on the work of Paris.
Yes, and Paris, I mean, the documentation is really well done. I was surprised. Last time I just saw some drawings, and now it's just well done. With probably there are some, as you told before, there's some links that are missing maybe, but besides that, the ideas and the brainstorming area and all this work they did with 3D modeling and trying to figure out this stuff. I don't know if you can, guys. Everything is well explained, but also, I mean, as for instance, my student Gerard is doing his documentation. It's nice also to have a little section with all the problems, like a little list of problems that you had, and like a shortcut that goes directly to how do you guys fix it, or you manage to find a solution. But besides that, I mean, it's really interesting, and I was really surprised. You did a great job, for my opinion, for just this first step.
Good. Also, would be good to have a set of references for the machine itself. Okay, since I mean Chirac now was showing us this, Lorenzo, I mean have a bunch of references that we can discuss about it. Okay, like the Arduino inhibitor that we showed before. This is basic, but it's good to have it clear. Okay, thank you, Lorenzo. I'll go to Digiscope. Romain, sorry for the wait.
No problem. How are you doing?
Good. We are here.
Good week.
We are here.
Yeah. What's up? I'm gonna comment first. Woman's work, maybe. I like it. I find it really complete documentation. Lots of. I like the sketches. I like it. I mean, it's a good way for people to understand the path you're following in your head, like to reach the goal of building a machine. And I think it's really completing the rest of the page, like the mechanical, like simulation and things like that. I had a question actually. Do you have any like 3D printed parts that receive liquids or stuff like that?
Yeah, there is the one that Guillaume did. Guillaume is doing at the end the final cap for the
black object. Okay, yeah. Which material is he using?
PL.
It is PLA, I think.
Okay.
PLA.
Yeah, PLA.
What are you planning to use for liquids? Because PLA won't make it like for too long. He's going to sink.
No, in fact, we will use you know, this kind of ribbon of I don't remember the name. Guillaume, can you give me the name?
Du Teflon.
Teflon.
Okay, I get it.
Teflon ribbon over it, just to solidify the connection.
Okay.
The PLA is enough strong to do not deformate during the usage, so the choice.
I would find it interesting, but like, I mean, it's not mandatory. But if you could try to use a plastic that makes it with liquids, if there's one part of it like that has to work with liquids, that would be interesting. Which we can talk about it if you're interested in that later.
Yes, of course.
Okay.
We are ready for any ideas, and anyway, we will test our solution. We are not yet.
Okay. Nice. Because I've printed several like tubes for experiments in biology for how to grow, and I've been trying like probably 12 of them, like putting bacteria into liquids inside. So I guess we could like, maybe make a try with something else, like another plastic.
Yeah, we don't need bacteria. Sorry.
No, but you're gonna get like a lot of them actually. Maybe you should like this could be like a cocktail machine with bacteria actually.
In fact, the kind of liquid we will distribute, there is no bacteria.
No, you mean it's too high in alcohol? Is it? Killing everything alive? Okay.
Kind of juice.
Okay, good. Going toward our page. So I opened the repo, but it's Andreas didn't use it. He used his own like week 9 page to show the work. So I'm sending it right now. I can actually, yeah, I'm going to share my screen. Maybe it's better. Let's see if it allows me to do that. Yeah, that one. Smart screen share. Okay. I'm not in the lab right now. So, oh yeah, I'm sorry, I'm gonna have to, I never did that before on that computer, so it's asking me to do a few things. Are you seeing something right now? Do you?
Yes.
Okay, good, awesome. So at the beginning, I really wanted our students to work on bio devices. But like I asked Neil last week, I think you heard it like during class, if that would be wise, and he didn't open the door, let's say. So we had other options, and the students wanted to work on a simple laser cutter. So I oriented them toward Mushira's project, Risha laser. In between, we've received the kits from Nadia. So we have the kits, but they didn't use it yet. But they started to kind of simulate it, like simulate the use of those in their own labs. So some people are in Jussieu, other people are in Polytechnique, and the last one is in Marne-la-Vallée. So they didn't have the chance yet to regroup, to make the job, so they work remotely. So at first you have like the parts that were designed by Apache, as you can see here. And then here you have Vincent and Andreas and Christian playing with Nadia's design. So they wanted to cut the cardboard parts. They had to reduce the size. I think their machine is not big enough. And it seems they managed to find the right setting. And they assembled a few things like that. And they started to discard a machine to remove the diodes and the laser, because that was their quest, to find a laser that would kind of make the job to start cutting maybe paper or something else. So they removed parts. I insisted on safety, so you can see their faces with those funny glasses. They're pretty well equipped to do this kind of job, to play with lasers and stuff, because their labs is related to physics. So I guess they know what they're doing. And so here you can see them playing with the laser on the paper, just like controlling the power of it, more or less. And that's it for now.
Wow, impressive, huh?
They're good.
There was no laser before in the machine week. It's the first one, no?
Yeah.
It's really impressive. In technical comment.
You want me to go up and down again?
No. This laser part again. What are you using for the laser?
What are they using for the laser? This is a laser. I think that laser is. Let me check. It's not very powerful. They had it from another machine. Like on this machine, this is a. This is a DVD burner, actually. They dismantled and they removed the laser from it.
But are you using like a CO2 tube and to produce the energy, or is it just like a normal DVD?
This is a normal DVD.
Ah, all right.
Yeah.
But
so, what?
No. Go on.
No, I don't have anything else to say.
Okay. And I just want to ask you, like, how is the XY axis working here?
That's their part. They didn't report to me yet. So they're not right now. They're working at the moment.
Yeah, in the drawing I just see the one axis movement.
Yeah, true.
Sorry?
Yeah, I think that they have more things they were supposed to upload, but they didn't have the time yet. Yesterday night they told me around, like, I think it was like 11 or something. So I guess we have more. I'm expecting one of them to upload something this morning.
Okay, cool.
That's where we are.
Good. Also, you did the test. What is the material you tested? Sorry? It's a foam. Okay.
Yeah, it's foam.
Yeah, that's a nice thing. Okay, good. I mean, it's very, very nice and well done. And it will be good to have at the end, this is one of the most expensive in a lab. So, I mean, it will be a good point to.
I didn't catch that.
It's one of the most expensive machine, no?
Oh yeah.
So,
you know the laser Zor.
Yeah.
That's the one you want to build. It's like cutting. I think it's cutting more than 1 centimeter of plain wood.
Mm.
I mean, like, I'm not even sure it would be interesting to reinvent that machine. You see what I mean? Like, it's fair because it's around. I think the cost would be around 8,000 or something if you build it yourself. So that would be interesting that one of our labs tries to build one.
Shirako was telling me that there is a laser cutting machine project from the Fab Academy of the previous year, but I
don't know if it is a Fab Academy, but do you remember the girl from Egypt who also won an award in during Fab 10?
Yeah, I mentioned her. This is Mushira I was talking about before, but it's a very small. It's very good. I mean,
no, it's very good, but I'm just saying, like, to look at it as a reference for your students to understand.
You're right, Chirag. That's the first thing I did.
All right,
that's great.
This is great.
Okay, super, Roman, and thanks for this is a good, really good feedback also for us to see another approach. Lorenzo, sorry, but without the documentation, for me, it was a little bit more difficult to catch the job that you guys did in Corsica. But I'm sure we will discuss about it next week. So just to sum up, now, and also I'm going to sum up and I'm going to throw the ball back to the other instructors. As I understood, finally today, Neil and Nadia will show us the new interface program, the new interface that we need to use in order to program the boards and move the motors. So this week will be about all the electronics and programming. So I still see that there are some important issues in Paris that we need to fix, but I'm sure that we will fix it and solve it. On our side, Mathieu just arrived there. I guess he's in volume, if I'm not wrong. So, I mean, we will see a little bit later what's new on the dish. So, Romain, you confirm, no? I understood properly. We're gonna see a new interface because at the moment we were checking the one in Python that we used last year.
Honestly, I have no news on that. I don't know.
Mm-hmm. Well, Emma from Amsterdam and also with Lorenzo, we got this.
Emma told you that?
Yeah, that's the feedback that we got at the end.
Okay.
But in any case, we still have the same, let's say, process of last year that can be a B plan, you know.
Okay, I see.
Good one.
Like a second buy option.
Yeah, an option B. Okay, that's it. Let's discuss a little bit later with Neil. I will try to propose our lab to present the work. Okay, so Tom, be ready because you will be doing the presentation. If I stop Neil and I get the opportunity to do to present it. Also, Roman, I would say from your side you should do the same. It's a really nice.
I agree. We should be like they should be 4 today in the afternoon. So I guess one of them will show up and say, "Hey, I want to do it." It's always Andreas mainly, but I'd like someone else to try.
Okay, that's good. Okay, guys. So we meet later at 3. With the students and 2.5 with the other instructors for the prep meeting. Okay? Bye. Okay.